Okay, now move. Good girl. Alrighty, so you want to detect an exploit using Zeek. I'll show you how. So first I'll show you the vulnerability. This is a remote code execution exploit in Redis. Attackers could connect to an unprotected Redis server, make the server a replica, and then sync the database. Instead of providing a Redis database file though, they provide a module file that's the exploit payload. Once this is loaded on the replica, the attacker can then load the module and run arbitrary commands. All this does is exploit intended behaviors, loading commands for a module and making a server a replica, etc. Any Redis server past version 6.0 is likely locked down enough that this won't happen. That also means that it's perfect for a demonstration. Alright. So first, we need to set up a Redis server. We'll call it Redis target. And I'm just going to copy paste these commands in, just since it's simpler that way. Alright, so we started the server up, and now we need to sniff network traffic. This isn't absolutely required, but this is necessary to get a packet capture so we know what we're looking for. Alright, don't worry about the specifics of that command either. Now we're going to run a script that I have here. So this script is actually going to perform the exploit. Here we go. So we see this slave of command up here that makes the target Redis server think that it's a replica, and then we sync over this elf file. You see the magic elf bytes there, and then we do module load. And since it returned okay for that, we know that we can just execute any commands now. So that module gives us a system.exec command, and so we can just run anything on that Linux Docker image. So like, who am I? It's actually Redis. It just has a buffer issue. So who am I? Redis. And then we can do like ls/ and we can see all of the root directory. We could even like echo hacked and put that in proof.txt or something, so they know that they've been hacked. And then see that we made that change on the file system, right? So, oh gosh, we were hacked. So now we're done performing this exploit, so let's just exit out. That ends up removing the exploit payload right here. And now we can stop the sniffer. And we now have this pcap file, redis full exploit.pcap. And so if we run this through Zeek right now, so -cr, so we're loading a pcap, and we just provide that pcap. Now we do ls_star.log, and we see redis.log, so we can see that here. This just logs each command and the response from the server, so we see like the module load, we see slave off it, and then we see these system.exec commands. So these are what we were running in order to actually perform the exploit. Cool. Now, imagine that we don't have a Redis parser in Zeek. How would you get this data, and how would you then create this detection that we want? Alright, so now we have a pcap file, but we don't know anything about it. Let's figure it out. So we will use Zeek for this, but you can use lots of tools. You can use Wireshark, you could just use TCP dump, you can use some random other thing you find on GitHub. We're just going to print TCP contents. Zeek, however, gives you an event node trigger for each chunk of a reassembled TCP payload. It's really slow, it's not production ready, don't use it except for debugging. We're going to use it here to see what's in a pcap. So here I'll write the script. I'll just call it all.zeek. First, we define two things in order to say, yes, we really want this event to trigger. So all originator. So this will trigger it for any originator request, and this will trigger it for all responders. Then we actually make the event, so it's called TCP contents. Then all of the parameters is orig, bool, sequence, count, right? Contents, string. So contents here is the important one. That's what actually gets you what's inside the TCP payload. I missed a parentheses up here. And now we can run Zeek all.zeek on this pcap that we got. Alright, so this is what is actually transmitted on the wire. Zeek escapes hex codes here, but you can see the basic protocol. Some character to start, like in this case $, or in this case the asterisk, or in this case a plus. And then you have data. And at the end you have 0D0A. This is a carriage return line feed. So that indicates a new line. Redis actually uses its own protocol. It uses the Redis serialization protocol. So we can actually go to the documentation for this protocol. Here it is. And we can scroll down and we can see all of these things that we saw. So we saw $. We saw asterisks, right? Where's asterisk? Right here. So asterisks are arrays. All of this, you can see exactly what the protocol is, and now we need to be able to parse it. There are differing opinions about how you can move forward. We could just make some detection using the signature framework, but I think it's more educational and better for Zeek in the long term to properly parse this protocol. Okay, so now we need a parser for that stream of bytes that we just saw. I won't go over the entire protocol, but I'll show you some basics about how you can parse this protocol. So, if you ever think, how do I parse some network data within Zeek? Your first tool that you go to should be called Spicy. Spicy is a protocol parser generator. As is, network traffic is just a bunch of bytes. So you create a parser that understands this bunch of bytes and it creates structured data. Spicy is just one tool to create these parsers easily. So let's start one. First, we need a spicy file. I'll call it resp.spicy since Redis' serialization protocol is called RESP. So now we declare a module. And then we create this unit. So units are just a thing that is parsed. Think about it like a struct or a class in a lot of programming languages. It's just a bunch of fields that you parse in a certain way. So if we go back and we look at the protocol, we see that it's like a first byte, and then it's some stuff, and then it's a carriage return line feed, right? That first byte in Spicy, that would best be done with an enum, because you have a bunch of things that are 1 byte long, and this byte can mean many different things, and it's obvious based on the ASCII code. So here we'll just call it data type, and it's an enum. Then we have a few, so like simple string, that was a plus, a bulk string, that was a $, an array, that was a star, right? And then also while we're here, I'm going to make a convenience constant. So this is carriage return line feed. So in Spicy, we're just going to use the hex codes for this. Oh, not B, X. Sorry about that. There are a bunch of types, but I'm only going to show you these 3. So the first thing that we do is we need to parse a type. We give it the type uint8, so we're parsing exactly 1 byte, and then we convert it into this data type enum that we have. And then we use this $$ to say the thing that we just parsed is $$. Now, if you have lots of different types and you want to parse them, then you use a switch in Spicy. So we're going to switch over that type we just parsed. And for now, we're just going to handle data type simple string. Then we create a simple string member within this message. And then we give it a type of simple string. We'll create that later. And then we also have an on%done. This is called a hook, and we'll just print self. So this is for debugging only. We should remove this in a production analyzer. Alright, now we're going to make that simple string unit because we use it, but it's not defined anywhere. So type simple string. Notice that it's not public like message. That makes it more efficient. Is a unit, and it is just content. Content is the name of the content within it, and it has a type bytes, and it goes until we see that carriage return line feed. Alright, so now let's see how it works. So if I just echo plus OK, carriage return line feed, and I pipe that into spicy driver, which comes with spicy, and then I provide my spicy file, then I wait a second, and I see if it parses it, because we have the print. And as you can see, we get a message with a type simple string, and then that simple string member is populated with another unit whose content is OK. Alright, so now let's do more. So we have two more types, bulk string and array, so let's do bulk string. So I'll just copy paste this line and change a couple things. So we are now going to use the enum for bulk string. We're going to call this bulk string, and its type is going to be a new unit we're making called bulk string. Alright, now to make this unit, it's just type bulk string is a unit. A bulk string, if we go back to this, we can actually click bulk string, and then we see that it is $sign followed by a length, carriage return line feed, and then data. So I will start parsing a length. This we'll just call it bytes because it's going to be in like base 10 when we're here on the wire. So we parse some bytes, and then we go until the carriage return line feed, and then we convert it into an unsigned integer. So $, that's just saying the thing I just parsed, so the bytes. And we're going to call this uint to uint with a base 10. And then same thing before, content, bytes, but now we're actually going to use this length as the length of the content. So I'm going to say and size equals self.length. Bulk strings are a way that you can actually put carriage return line feed inside of your payload, so we need to just parse the length regardless. We should have some limits on this. We won't show it here, but we should have some limits on this because a bad actor can say, well, I have 1 trillion bytes, and then you just parse 1 trillion bytes and store it all in memory. That could mess up your Zeek, right? And at the end, we're going to skip the carriage return line feed with a skip keyword. Alright, and now we'll just test this where we'll send it over a bulk string. So echo, we escape the $sign, and then we say it's length 5, carriage return line feed, hello, carriage return line feed. And we pipe that into spicy driver. Oops, sorry about this. That K is not capital. Alright, so then we pipe it into spicy driver, and we get a bulk string where simple string is not set. So any fields within a unit are optional by default in Spicy, so you're just going to see it as not set when you print it. And then this bulk string is actually optimized out here. So if you actually want, so sometimes we optimize out fields. If you want to see this content field, you can actually say always emit. And we do the same exact command. And then here we can see it gives you hello. That'll be done for you if you have Zeek integration, so you shouldn't have to worry about it too much, but it might be important when debugging. Alright, so now last thing, we're going to make a recursive type, and that's array. Alright. Oh, that's capital, sorry about that. Alright, so here we have a new thing where we're going to try to parse an array with a unit called array. So array equals unit. And then an array is similar where we parse the length, so I'm just going to copy that exactly. And then I will show you the protocol again. Here we can go back and we can find arrays. So arrays are just star number of elements, and then it goes with each element. This is recursive, so each of these are just a RESP element. So we can do that within Spicy. We can just say elements are message, the thing that we have, and then we provide the length. All right, so now we're going to test this out. And so echo star, so star is what means it's an array. We'll give it 2 elements. So character return line feed. We'll do a bulk string with 5 elements. Character return line feed. Hello, character return line feed. Another 5 elements. Character return line feed world. So this is an array with 2 elements. One is hello, one is world. And we pipe that into Spicy driver again. And then we can see, so this is the inner bulk string. So since it's recursive, the inner types are going to finish parsing first. So these are the 2 inner bulk strings, one saying hello, one saying world. And then this is the array that contains it all. All right, so this isn't close to all of Redis or RESP. But it should give you a good place to start. So now let's integrate this with Zeek. Okay, so Zeek parses a large stack of network protocols, so TCP, IP, etc., that eventually get to the Redis serialization protocol. Most of that is abstracted away, but we'll still have little pieces to fit together to glue this parser we just made into Zeek. For that glue, we're going to use Zeek Spicy integration, which is called spicyz, and a .evt file. So let's make it. First, we define the analyzer. So we'll call this resp.evt. It's a protocol analyzer called RESP over TCP. And we parse with RESP message. So that's the unit we made in the other file. Then we import the RESP module. Sorry, that is not indented. And finally, we define the events that we want to send off to Zeek. Here we'll define one for each message type. That's pretty different from how it's implemented in Zeek, but it's just for demonstration. So whenever we see a simple string, we raise an event resp simple. We pass in the connection, we pass in whether or not it's the originator, and then we pass in its content. So these ones with $signs are actually built in and provide for you. You just need to provide into the event if you want it. Then we'll use this, the exact same thing, except call it bulk. And we'll go resp bulk string. An array, resp array. Here we don't have a content variable. So we're just going to pass it in like that. All right, now let's move on to Zeek. So we'll call this resp.zeek. We'll put in module resp. Here we need to define what ports we actually want to listen on. So I'll do this using what is essentially the standard Zeek style for doing it. So const ports equals 6379, that's the standard res port, TCP. And we are able to redefine it. So we could add that 21,000 port if we want. Redef likely server ports. We add in the ports that we have up there. And now we need to actually enable the analyzer on those ports. So in Zeek.net, analyzer register for ports. And then we provide this auto-generated analyzer resp, and then ports, and that will enable our analyzer on all of those ports by default. And then for each of those events, we defined an EVT file. Let's just write a little handler here so that we can debug it. So event for simple C connection is originator string, and here we'll print simple with the content. Then we do the same for the other two, but for arrays we just won't print content. Alright, now let's save and exit. And we can compile the analyzer that we wrote in Spicy and the .evt file with spicyz. So spicyz resp.evt, resp.spicy, and we output resp.hilty object file. And finally, we will load Zeek-cr with Redis full exploit.pcap, the capture file that we took before, resp.hilty object file, and then resp.zeek. So something's a little bit off here. If we saw before, do I have all.zeek here? I do. So if we saw before, we have a bunch of commands, but when we ran it here, we only got one. We got exactly one from each side. So what is actually happening here is that once the parser parses one message, it says it's done. It doesn't care. It's not going to continue. So we actually have to change this. So resp.spicy. See how we only parse one unit? We actually need to parse many units for TCP payloads. So we'll make a public type messages. And here we're not going to store anything. We're just going to parse a bunch of messages indefinitely, forever. Then we open up the .evt file. We change this to resp messages. And now let's recompile. Sorry about this. Need a semicolon. Alright. Then we recompile. And then we run what we had before. And now we can see all of those commands. Just like hacked and who am I, the things that we ran. So this is just the start of a parser with Zeek integration, but it should give you a good grasp on what the end-to-end flow with Spicy is. You can even go in and implement the rest of RESP yourself. We're going to go in and act as if it's already done for us, which it is in Zeek's RESP parser. And then we're going to make a detection. Alright, so we've seen how you would get started with Spicy in order to detect this vulnerability, but now we'll put a nice bow on it by assuming all of the protocol parsing and logging is done in Zeek, because it is. And so we can see how to detect it. So first, what's necessary to detect this vulnerability? Well, one, the server must be unauthenticated, so anyone can connect to it. That's hard to detect over network traffic. Two, the client which connects will tell the target server that it's actually a replica via a slave of command, and then it will load the module with the module command. And three, this controlled server will send an ELF file as its database on a resync, which is weird. The first can not be detected by Zeek, really. Your Redis server should be authenticated, firewalled, whatever. We won't deal with that. The second and third, we can definitely detect on the wire. I was spoiled for point 3 though. It's detectable, but it's actually not the Redis serialization protocol. It looks really like it, like the full resync command. It comes in as a reply in the parser, but there are a bunch of weird things with it. So there are more than one reply per command. It's actually internal communication within Redis though. Zeek only marks it as Redis traffic because of DPD, or dynamic protocol detection. We can configure some notices for abnormal commands though. If we look at Zeek's documentation for Redis, which I can bring up over here, so docs.zeek.org, here I'll go here, we can actually look up Redis. Click that, go to spicy events, and we can see if we want to, say, have a bunch of commands that we want to send a notice off if they're ever used, well, we can use this Redis command event generated for every command sent by the client to the Redis server. Alright, so now let's use that command event. Alright, so we're going to actually make it allow list, so we'll call this allow list commands.zeek. And I'll just copy paste this file in and explain it, just since it's a little large. So here it is. So here we create a module called Redis RCE that will be important, especially for this allow list that we have here. This is a redefinable global. Here we allow a few commands like ping, config, just stuff that this server was using. Module is probably a little controversial here, but it might be used in normal execution. Basically, these are commands that we're okay with seeing on the network. Then we define a new notice. This is what's going to be in Zeek's notice.log. And then we listen to this Redis command event. Here we check it if the command name to lowercase is not in the allow list, and if not, then we fire a notice. Alright, so let's run it. So the same full exploit.pcap, and then allow list commands.zeek. Now if we list all of the log files, we can actually see we have notice.log. So let's look at it. And so we have a couple of disallowed Redis commands. We have slave of, and we have system.exec. There were a few system.execs, but it was deduplicated by the notice framework. So now you can actually customize this allow list. Let's go back in. Really, this could be like an option. This will give us extra capabilities later. So if we define it as an option, get rid of redef because options are redefinable by default. Now we can say all of this, and then the module name, allow, and add in slave of. So because so maybe slave of is an important command for you, and so let's run it again, cat notice.log, and here we can see that notice entry is missing. It's just system.exec. Alright, we can even redefine it in another Zeek script. So let's go in here, redef res rc allow plus equals slave of. And then same command as before, get rid of that, instead load in this redef it.zeek. And now cat notice.log. Same thing, so system.exec, but not slave of. Now, if you want to get fancy with it, you can use the config framework. So here we use an option, which means that we can actually modify this using the config framework. So I'll make config.zeek, and here I will say config files plus equals, and let's make a Redis allow list.dat. Sure. And then make that file Redis allow list.dat. So then we have the module allow, that's the option, and we just set it to what we want. So here we say ping, we say config, we say repl.conf, psync module slave of, right? And then we run the same thing. Instead of redef it, let's run config.zeek and cat notice.log. Okay, so you probably noticed that this actually still has this slave of command, so that shouldn't happen. The reason for this is actually a pretty big catch-up for the config framework. So reading the pcap is often way faster than loading that file, that config file, and it doesn't load in time, so it just uses what's in there already. So the solution here is to block pcap processing till the input framework finishes. So here I'll just add this to config.zeek. So event zeek init, and we suspend processing. And then when we reach end of data, the input framework generates this event. The config framework just uses the input framework under the hood as a string, source string. And then if config is in name, then continue processing. So now if we do the same, we'll remove notice.log so that you can see a difference. Do the same command as we just did. You see it says processing suspended, processing continued. Then cat notice.log, you see that it's missing. We can then go into this, res allow list file and say now we actually do want to detect module, right? So we remove it from the list and then we run this, cat notice.log, and you see that module is in here. All right, so there's 3 different ways to configure the set of allowed commands so that you can tune this detection to your liking. Alright, thank you for watching. I hope that everyone that watched this can go off and write their own detection now or their own spicy parser. If it helped you or you build something cool from it, let us know. We'd love to hear it. Thanks. Meow wow.